In order to prevent problems with crude instability, incompatibility, and fouling, refiners have multiple commercial options they can use. These options include commercial analyzers, methods, models, and software to predict crude compatibility, fouling, and stability. There are analytical methods and analyzers available on the market to help refiners determine the stability of crudes as well as potential fouling issues. Here is a non-inclusive list of commercial analytical methods and analyzers to determine crude stability and fouling. Here is our sponsor's experience. The Asphaltene Stability Index Test, or ASIT from Baker Hughes, a GE company, is a tool for determining asphaltene stability of crudes and crude blends. Field ASIT Services technology uses a portable automated titration device using near-infrared laser to detect onset of asphaltene flocculation. The testing can be routinely performed in the refinery. The ASIT plot is the normalized laser power intensity on the y-axis versus the asphaltene stability index, or ASI, on the x-axis. The curve inflection point is the asphaltene flocculation onset and ASI value for the test. In the chart depicted, the black curve represents the base crude for the refinery with a moderately stable ASI value. The blue curve is an opportunity tight oil with no well-defined flock point. Additional information is required to define the ASI value of this type of crude. The red curve is the targeted blend of base crude and opportunity crude, demonstrating a very unstable crude blend that will require problem mitigation. Blend asphaltene stability information can be used to help guide crude selection, blend ratio decisions, and problem mitigation planning to manage risk and maximize refinery profit. Data obtained using the Field ASIT Services technology can be coupled with the BHGE crude compatibility model to further evaluate blend stability for new and proposed blends. There also exist commercial software and simulators that predict fouling in refinery equipment. Here is a non-inclusive list of commercial software and simulators that can predict fouling in various parts of the refinery. There are commercial analytical methods and analyzers to determine crude compatibility. Here is a non-inclusive list of commercial analytical methods and analyzers to determine crude compatibility. Finally, there are commercial compatibility prediction models that have been developed to determine crude compatibility. Here is a non-inclusive list of such prediction models that can determine crude compatibility. Additional information on these companies' technologies as well as information on products and services previously mentioned can be found in our just published strategic report entitled Novel Strategies of Processing Price-Advantaged Crudes in a Volatile Oil Market. Here is our sponsor's experience. The BHGE crude compatibility model is a proprietary mathematical model that can estimate the ASI of a crude blend based upon the ASI values of the individual crudes and some additional crude characteristic values. The example plots depicted are simple two crude blends. The blue data represents the model calculated ASI value on the y-axis versus the blend percentage on the x-axis, 0 to 100%, of one of the crudes in the blend. ASI measurements of physical blends are also plotted validating the model values. Blends containing as many as 8 different crudes have been modeled and lab test validated in a similar manner. The values used in the crude compatibility model can also identify the theoretically defined incompatibility points for various crude oil blends. These would be blends that potentially should be avoided, or more extreme mitigation efforts required. A crude oil database can be developed to facilitate planning of how a new crude, or a new crude blend, may impact the refiner's operation with respect to asphaltene stability. The model also facilitates ASI quantification of various crudes that do not produce a well-defined flock point. How these no-flock crudes behave in the blend is of strong interest, as many of these crudes induce asphaltene instability.